Okay, today we're going to talk about properties of exponents, and this isn't a subject that we're probably really comfortable with yet, so this will take us some time to work through. The first property of exponents is the multiplication, and when we see like bases and then exponents, when we multiply, we're going to add the exponents. Okay? So when it's multiplication, we add. So let's go over here to division, this one right here. When we divide like bases, we can subtract the exponents. And then the third property that I'm very comfortable with, as far as these are the base three really. When you raise a power to a power, you multiply. So we have a to the m plus n when we multiply, a to the m minus n when we divide, and a to the mn when we raise a power to a power. Now the rest are kind of built off of these principles. Like the power of a product, that simply means a to the m, b to the m, because these are both ones. We more or less distribute the exponent, okay? Then, same way here, we can kind of distribute the exponent on the other exponents. M times 1 is m, and b times 1 is m. And they're not like bases, so we can't subtract them. Same way with this one. And then the other two are kind of just ones we need to memorize. A to the 0. Anything to the 0 power is not 0. It's 1. Okay? And then the negative exponent property, anytime you move a number with an exponent across the division line, the fraction bar, you change the exponent sign. So instead of a to the negative m, we have 1 over a to the m. Okay, so that's how we make it positive. We just move it. So now the examples are just based off these properties, these 7 properties up here. So on number 1, we're raising a power to a power, which in this case is a to the mn, so this is 6 to the 6th, 2 times 3. Number 2 is this property, the negative exponent property. How do we make that negative exponent positive? We put it in the denominator. Now we can evaluate these, but these numbers are huge, so we're not going to waste our time with that. Number 3, we're multiplying like bases. What do we do when we multiply like bases? We add the exponents. So that's 3 to the 3rd plus negative 2, which is 3 to the 1st. Or just 3. Number 4 is just like this property right here. That's going to be 3 cubed over 7 cubed. Now we can evaluate all these if we take our calculator, which I'm not, but we'll go ahead and do quick. So 6 to the 6th is 46,656. 7 to the 4th. It is 1 over 2401. You see what I mean? We don't really need to do these because we're just worrying about the exponent properties, okay? Now, when you get to 5 through 8, you're going to have to do some thinking, okay? So now we got x's, but we still are looking at the exponents. So on number 5, you can see that we're raising a power to a power in the numerator. So we multiply those. So that's x to the 15th over y to the 6th. Over x to the 15th over y to the 8th times y to the 8th. Now, the x to the 15th, we're dividing. Now remember the divisor, we subtract exponents. Well, 15 minus 15 is 0. So it'd be x to the 0, which is 1, so these more or less just cancel out as 1. So now you have y to the 6th over y to the 8th. Now what do? Well, the bigger number is an 8. Therefore, we're going to move the 6 down in order to keep a positive exponent, because we have to have a positive exponent. That's part of our deal. I didn't mention that earlier. So that's 1 over y to the 8 minus 6. When we move it down, becomes negative 6. So that's 1 over y squared. Okay? Number 6 is just like this property again, the quotient property. So that's a to the negative 8 over b to the 4. Now, here we go again. We have to have positive exponents, so we're going to move that a down and make it positive. So that would be 1 over a to the 8th, b to the 4th. 7, we're going to combine a whole bunch of properties here. Okay, the first one being we're going to distribute that exponent, and we get negatives, right? Well, remember, to make them positive, we're going to move them up. So that would be 3x squared y cubed, but then we'd have 4 squared x squared and y squared, because that's going to make them all positive exponents. And now you just do the math. Do your magic here. 4 squared 16. 16 times 3 is 48, so we got rid of those. X squared and x squared is x to the 4th, and y cubed and y squared is y to the 5th, because we add the exponents. That's the product powers property. So it's 48 x to the 4th, y to the 5th. Okay, number 8, again, that's a 1, so it's 3 cubed x to the 6th over 6x to the 4th, which is 27 x to the 6th over x to the 4th. Let's see if you can figure this out. 3 goes in there twice, and 9. So we have 9 over 2. Now what's bigger, the 6 or the 4? Obviously the 6, so we move it up and subtract. So that's an x squared, 6 minus 4. If the 6 was in the denominator, we would go the other way. So you could put this on pause and replay it and look at how to simplify those exponents if I'm going too fast, okay? Now the last little nugget here are fractional exponents. And what this means is, this is our root. This is our power. So it's x to the 1st, the nth root of. We say the nth root. Now we've done square root, but now we can do all the roots you can think of. So this is x to the m to the nth root of x to the m. Okay, so cube root of 5, how do we write that? That can be written as 5 to the 1/3, because this is a 1. 3 is our denominator, like here. That's this one, or this one, sorry. So this is a 2, because we say square root, so this would be 13 to the 1st over 2. So 13 to the half. Next one would be 10 to the 7/3. And the last one would be 15 to the 3rd, the 8th root of 15 to the 3rd. So look at those. Oops, sorry. I was supposed to make that to the exponent, right? So that'd be 15 to the 3/8. Sorry. 15 to the 3/8. Now on the other ones, we're going to go the other way. So this would be the 4th root of 5 to the 1st. This would be the 5th root of 14 squared. And this would be the 3rd root of 2 squared x squared, which is 4x squared, because we got to distribute that 2x is squared. So that'd be 4x squared. Notice the root is the power underneath. That's your root. And this completes our lesson.